Hello, watchers and listeners. Keep up your learning attitude. Stay up to date knowledge. Welcome to IGBits. We train, you learn. Today, we shall continue remaining subtopics of median, which is a part of your measure of central tendency. Let's get started. I wish I would like to let you know that we have a YouTube channel, the channel name IGBits. Feel free to log into YouTube and then subscribe the channel. Your support is very important and essential for us to sustain the channel information, keep updated, and then your helping hand will support us to build the more knowledge and then sharing across, right, all the people who are like us to actually get the access and then learn the unseen topics. Okay, and feel free to share the channel to the your circle so that we can extend our helping hand to the rest of the world. Thank you all for keep staying with us and then keep help expanding our channel data to rest of the world. Okay, let's look at this specific data set, which is very important, and then we can derive a couple of concepts from this data set. First thing, when you look at a data set, what is you are seeing? The data is not in the order, right? So you would be doing arranging an order. The order would be increasing or decreasing. Here we are actually taking the increasing order. So I rearranged them all. If you look at, I think 1 to 15 of series number is what we get your sample data set. Okay. So one quick note is like when you have this kind of data, what would be the mean? We know, right? First n natural numbers for which you have to calculate the data. N plus 1 by 2, isn't it? What is n value here? 15. So 15 plus 1 divided by 2 is nothing but 16 by 2 is 8. So 8. 8 is the mean. Is it? So look at the mode also. When we have median. So for median, what you are saying, your number of observations are 15, which is odd number, right? Your observations are odd, correct? So which is n equal to 15, and hence n plus 1 by 2 would be your median, right? So 15 plus 1 by 2, which is nothing but 8. Do you see that one? For this kind of a data, what we got is mean equal to median. So for if you look at the data equally distributed, right? And then what does it means? Like the left side samples and right side samples are actually having similar kind of property, and that is the reason mean fall under median. Otherwise, mean will actually shift towards right or the left based out of the data sample what you have. That is a special case that talking about. Now let's see from the given data. This is a min value, this is a max value. So min value is 1 and max value is 15, right? So what is median? Median is like 8, which is also called as a Q2, right? And then Q1 means like these samples you take it, these data subset of the data set is what you have to consider, and then you calculate a median for these to get the Q1 quartile 1. So 1726, right? That is how we see how many samples you have. We have 7 samples, and then this would be your Q1. Similarly, look at here, how many samples you have. Is it? So left, right, 3 you can remove, and then only the 12 is left out. So this is a 12. This would be your Q3. Correct. You got a quartile 1, quartile 2, and quartile 3. If you look at this in a total 15, then obviously 25% would be your 4, and 75% of the total observations becomes like a 12th sample. So that's why like 1, 4, 8, 12, 15 would be. We said like, max value can also be considered Q4 sometimes. What is a quartile range? Quartile range, the deviation. This is what it is it? So Q3 minus Q1 would be your intra-quartile range, IQR. What is the value here? 12 minus 4, which is nothing but your 8. Intra-quartile range is 8. Now, what we have to see, like from the given data, how do you calculate the outer layers? So we spoke about this topic, isn't it? Okay. So by looking at this, one thing I reminds, when you calculate the range for the healthy range, right? For the given data, we have to understand one important term, Q1 minus 1.5 IQR to Q3 plus 1.5 IQR. This is where I think we have to take a min max, calculated min max for the range to identify the outer layer, outliers. So look at this one. What is the Q1 here? Q1 is 4 minus 1.5 times 8. Right. So 4 minus 12 equal to minus 8. Minus 8 would be how much? This min value is, given value is 1. So this value probably somewhere else here. So, and hence we can consider this is our min, because no sample, no observation outside of the min value to the left. So we are good. Let's look at the right side. So Q3 plus 1.5 QR. Q3 means like how much? Which is at 12 plus 1.5 multiplied by 8. So 12 plus 12, is it? 24. So 24, where would be the 24? 24 is again, we have 15 is a max value, but the 24 somewhere else here, right? So our given data set within the range of these two limits, right? That means there is no outer layer in this data. Are you clear? So sometimes what happens is like you can have a sample data which is outside of the range, outliers. I'm pronouncing correctly, outlier. Okay, so if the data sample between minus 8 and 24, that you can consider. If outside of this range would be outside observations, you can say like observations outside of this range can be considered as outlier. So can be taken out from your observation data for further analysis. This is one of the important business case of identifying outer layers in case of like fraud detection. Like so bank frauds, you might hear that the most frequently fraud cases are recording in the real time the business case, right? That is where I think you can understand how the data sets are being formulated versus like identifying outliers from the given data set. This is one method that we can leverage to do that. So are you clear? Okay, let's try solve this problem. Measuring all the quartiles, IQR, quartile range, finding a outliers. You know, this is a given observations within the data set. How many observations I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So n equal to 13. So this is an odd number, right? So then median is 13 plus 1 by 2, which is nothing but your 7. Seventh element, seventh observation would be your median. Seventh means like one, you don't know this one, right? We have to put them in order, either increasing or decreasing. In our case, we are doing like increasing order. Let's increasing order, we can arrange them all. So let's say this 13, 13, okay, I cross 13, I bring over down. Then I have 15, okay, so 15, okay. Then I have 16 is 17. I have 17 done, and I have 18 too. I have 18. Okay, then what would be next one? Maybe 21. I have 21. I have 23, and then I have 25. Okay, 27 I have, and then I do have 28 too. 28 and then 29 as well. Then I have 32, right? And I have 38 and then 60. All right. So let me change my color pack again, just to be sure I'm not messing with the data. So I arranged the data. Now what you have to do, we have to look at the seventh element from this order. 1, 2, 3, 4, 5, 6, 7. This would be your Q2. So your Q2 is a median, right? So for the given data set, this value is at 50% level. This is called Q2, quartile 2. Okay, the value is 25th, the magnitude. And then mean value, what is the mean value here? 13. What's the max value? Max value is 60. But how do you calculate Q1? How do you calculate Q3? So this lower half of the data set is called, you take this sample and then calculate the median for this one. Similarly, take the upper half of data set and find out a median for this data set to get the Q3. Let's do this now. How many are there here? 6 elements, right? This sample is 13, 15, 17, 18, 21, 23. That's a distribution. And then here, what is the distribution here? 27, 28, 29, 32, 38, 60. This is second sample. So let's see the mean value now. I'm sorry, median value. How do you calculate? Cut this, cross these two, and then you remains 2. The mean of these two, 17 plus 18. 17 plus 18 divided by 2 is called 17.5. So this value is 17.5. Similarly, you calculate Q3. So probably this is the middle. So 29 plus 32 divided by 2. So how much this is? 61 by 2, right? So 30.5. This should be 30.5. So now we know Q3 and Q1. So IQR, interquartile range, would be Q3 minus Q1. How much that value would be? 30.5 minus 17.5. So what value would be? It's nothing but 13, right? So the range, actual range, how you are going to calculate? Actual range can be calculated in the two ways. We have to calculate the Q1 minus 1.5 IQR to Q2 minus Q3 minus 1 plus 1.5 IQR. So this is where I think upper limit and lower limit to calculate the range. So now we know that Q1 value 17.5 minus 1.5 times 13. How much? 17.5 minus 13, right? 13 and then F 6.5, 19.5, which is nothing but minus 2, right? This value. Look at this one, Q3, 30.5 and plus 1.5 times 13, it's like 19.5. How much this value? This is 50, right? So your sample data that you are considering between minus 2 to 50. If anything outside of these two sample data, minus 2 and 50, anything outside can be considered as an outlier. For a given sample, if you look at, right, what you are seeing here, minus 2 means somewhere else here, let's say. So, but your mean value is within the your range. So this is fine. There is no sample to be considered as a outlier in the to the left side, right? So look at the right side. Looks like I have 50, right? 50 is the my max value should be, but what I have is like a 60. So this sample, this observation can be considered as outlier. This is not going to help me for my, drawing any, critical information from this data. If you include this, can be considered as outliers, right? Are you clear? We can represent this in box plot, something like this. So I have, put this kind of box, and then this is your Q1, this is your Q3, and this is middle one is a Q2. Right? This is a min value and max value. In our cases, like this was a range, and then so this minus 2 is outside, so I can consider min value as a 13, whereas in this case, like the max value would be 50, right? Not 60. This is my box flat. Okay. So let's review the previous problem. Given data set is this much, right? And then we know that all the samples is basically 13, and then median we calculated. Median is like a 13 plus 1 by 2 is a median. Seventh observation would be the median, which is of 25th, right? This is what we discussed. So 25th is Q2, and then min value is 13, max value is 16 from the given data set. And then you found out a Q1 and Q2, which is of same. And then Q3 minus Q1 is also identified. 30.5 minus 17.5, which is nothing but your 13, the value. And then, so if you can actually plot the graph, what you have to see, the box would be, start from Q1 and with the Q3, and then wherever you got a Q2, the Q2 would be the same, right? So this is one way, right? The box. But what are these extremes? The min values and max values can also be noted. Here, what you are say, like the actual range is what we have to calculate. This is a intra-quartile range, but you will now extend the practical limits of Q1 and Q2 by calculating the range. How do you calculate the lower side? Q1 minus 1.5 IQR is called IQR. Okay. When you do this, IQR, interquartile range. When you calculate the left side, what we got is like a minus 2. So minus 2 somewhere else here, is it? So from a given data set, the 13 is inside of a lower limit, and hence I don't have any outliers. I don't need to remove any data set from this layer. When you look at a max value with respect to range, which is of 50, right? But what we have is the data is like how many observations are above 50 is like one observation. This is called 60, right? this is the outlier. So actual range is actually the 50, but your data is outside. The 60 is like outside of this range, and hence I can consider this is like outlier. I can remove it, and the rest of the data I can I can take it as a valid data set. I will redo the exercise to get the right values. So this outer layer is very important because sometimes we need to eliminate from this data. Sometimes precisely we need to identify outliers from the given data set based out of the business case. For example, in the real-time scenario, you know, precisely in the bank business, fraud detection is one thing that is important, which is like a rarely occurring events. If so, in that case, identifying the outlier is very important. This is one of the way with which we can identify. But the concept is, I think you have to be clear on the concept. Anything can ask, right? So find out a median of the given data set, find out the Q1, find out the Q2, or the quartile range IQR, or the actual range, to validate that data set, identifying the outer layers. So these are all the concepts, advanced concepts which you can understand part of the median using the box plot. Okay, this is a very important concept in the statistics when identifying measure of central tendency using median. I hope this is clear. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. We reached at the end of the session. Thank you all for who are actually made it today class. Let's meet in next session. See you tomorrow. Have a good day. Thank you. Bye bye.